In the past, many analysts and designers would say to ignore implementation. This is no longer the case. With modern software development and modernization, there is much more to think about. For example, a three-tier design will provide flexibility, but it requires constraints from the very early stages of design. A solution delivered over the web has many architectural constraints when compared to a traditional client-server application. Multi-channel deployment expands on these considerations further. There are no fixed rules about how a system should be componentized. The core aspects of OO theory and design have proven to be a successful approach. A well-engineered component should implement a discrete, reusable block of functionality. The size and scope of the object is determined by the designer. It can range from an entire application subsystem through to a business domain object down to a low-level technical service. An object may itself be a composite of other objects. Whatever the size of the component, it should be independent of other objects, that is, loosely coupled with a distinct role and responsibility. An object should employ the concept of data hiding, only exposing data and behavior through published properties and methods. Design by contract means that given the interface of an object, the consumer does not need to know about its physical implementation. As long as the interface matches the design definition for the operations, parameters, and preconditions, etc., the consumer can assume the object will work as expected when activated. The component developer does not worry about how the object is consumed. They can therefore focus on implementing and testing the business function of the object. Using this approach to application design, development, and modernization yields agile, maintainable software. Componentization is one part of the equation in modern application development. Software architectures tend to follow a layered approach, commonly referred to as N-tier architecture. At a high level, one of the most common arrangements is the three-tier architecture. In this scenario, software components group into three distinct layers. The first is the presentation tier and is only concerned with end-user interaction. Using the predefined interface, the presentation tier interacts with the second layer, which is the business tier. The business tier is the layer that implements the business functionality. It in turn passes data to and from the data tier. The data tier does the actual work of interacting with the data stores, hiding the technical complexity from the business tier. By adopting this approach and adhering to the design by contract concept, it is possible to change any of the components and still achieve the same business functionality. A change to a component will have no impact on other components or layers. It can be tested independently and deployed easily. For multi-channel deployment, additional presentation layers can be built. The alternative layers will only contain code specific to the chosen interface. All business and data logic is reused. Multi-tier architectures provide flexible deployment. Unlike a monolithic application, the component parts of a solution can be distributed across machines, technologies, and service suppliers. This offers scalability, performance, resilience, and many other benefits. The Uniface APS has long supported SOA architectures and component-based development. The Uniface component types fall into the common categories of presentation, business, and data. Forms, server pages, and reports provide the interface the user interacts with. These can share the business objects that comprise of services, session services, and entity services. The business tier communicates with the data layer, implemented through the Uniface data model and DBMS drivers. Specific details about the Uniface component types can be viewed in a screencast titled Introduction to Uniface Component Types. Service-oriented architectures add another view to the concept of componentization and end-tier architectures. In the case of a SOA application, a focus is placed on providing business functionality as independent services to network consumers. An evolution of this concept is known as software as a service. The widely accepted standard communication mechanism for service-oriented architectures is web services. In practice, any protocol can be used. However, the industry have chosen web services, so to maximize the return on investment and future interoperability, this technology is a sensible choice. SOA approaches provide a very effective route to modernizing applications. It provides a flexible way to deliver business functionality to the service consumers. Uniface provides support for the production and consumption of web services, allowing SOA development and modernization. Existing applications can be modernized through componentization. Every application has varied characteristics and business drivers for modernization. This diagram shows a high-level process for modernizing an existing application. The first phase is a discovery, during which the application is analyzed and business drivers identified. The existing application is then optimized to provide the best baseline for future development. During the extension phase, business logic is packaged into reusable components. These can be exposed as SOA objects. Upon completion of this stage, the application is fully componentized and ready for further extension and transformation. The transformation phase may include offerings such as software as a service, modern Web 2.0 interfaces, mobile deployment, and so on. The key is that the application is now at a state where it is easy to maintain, manage, and extend. To summarize, componentization is a good design approach to follow and gives many benefits. For example, a resultant application that is agile, reusable, and simple to maintain. The simplified maintenance and testing reduces risk and gives a higher return on investment. Component-based architectures give flexible, scalable deployment opportunities. As a tool, Uniface fully supports and promotes a componentized approach to deliver software solutions. It is fully SOA capable and embraces componentization through its technology independence. This concludes the presentation. Further screencasts can be found at www.compuware.com/Uniface.